Hi, I'm Yannis Roussos, the product manager of the memory group, and I'd like to take you through what we're planning to achieve in GitLab 15.3, which is scheduled to be released on August 22nd of 2022. So our top priorities are more or less the same as the ones we had for the past few milestones, but we have seen traction on multiple fronts. So I have multiple new exciting things that we're working on to discuss. So the first top priority is investigating the Puma long-term memory use. Puma is our web servers, and we have observed that the memory of those servers kept on increasing during when we did not have any deployments. We have fixed this problem, but during that effort, in order to continue and figure out what's the main memory runaway problem, we have identified the need to automatically collect diagnostic data from production Puma instances. The reason for that is that we cannot continue with such a deep dive by only using, for example, Prometheus metrics or logs that we store on Kibana. We have to run those diagnostic reports, like, for example, JMalloc, Ruby heap dumps, etc. A problem there is that in order to do so, we don't have access to production servers. So we have every time to ask an SRE to help us. So we want to build a way to collect those diagnostic reports, to generate and collect. So in the first iteration, we will focus on producing those reports on a running Puma instance. We will worry about collection in a later iteration. So at this first iteration, the collection of the reports will still require an SRE to help us and to fetch them and analyze them. The interesting part here is that we have to assume that most of those reports and diagnostic tools incur a significant cost and may interfere with certain user traffic. So may interfere with the availability of our nodes, which is the most important thing. So we have to make sure that these reports are generated and collected in a way that minimizes impact on node availability. Our second effort on this part is also identifying the use of diagnostic reports, especially the ones that require SSH on the nodes. So for example, generating various different reports like the Ruby heap dumps, process maps, SIG dump, etc., and then running a few sessions during 15.3 to make sure which ones are the ones that we really need in order to be able to do our analysis and our investigations. Next one, which is related to the previous ones as well and to memory users in general, is tuning the JMalloc settings for GitLab.com. The JMalloc is a variant of the malloc library. This is the way that our code takes memory. So the problem here is that we have never managed to tune JMalloc for GitLab SaaS, for GitLab.com. But now we have, first of all, we have added JMalloc stats, and secondly, when we are finished this effort, we will be able to also collect them. So we are planning to use those JMalloc stats to fine-tune the settings of JMalloc in GitLab.com. The thing there is that because it is not tuned, it can result in ever-growing memory usage for GitLab.com. Next one, which is also an effort that has spun off from the investigation for the Puma long-term memory usage, is considering replacing the Puma worker killer. And this was initially, we figured out that Puma worker killer did not work correctly. That's why the memory was increasing. So the main task of Puma worker killer, it is a process that monitors the memory that other processes are using, and when it passes a certain threshold, it kills them, it rips them, and also occasionally rips workers based on a timer so that they are refreshed. The problem there is that, first of all, it uses RSS, which is not a poor measure of real memory. The second problem, which is even more important for us, is that those memory limits are static and are very difficult to tweak them. So we set them once and we cannot change them dynamically, for example. And the third problem is that even when we change them, we have to change a lot of things inside GitLab. So for example, if we change the limit of how much memory a worker can take, we have to go back to Omnibus and change how many Puma workers should run by default, and many other changes. So our approach here, our idea here, is to add a new memory watchdog for Puma. And the idea here is that instead of doing a static memory limit, is to use heap utilization instead. So how efficiently the workers are using the heap, are using the memory. And our idea is that high memory use is not a bad thing as long as it's used efficiently. So our plan with this new memory watchdog is to make sure that all workers maintain high heap utilization, so they use the memory as efficiently as possible, but at the same time avoid node memory saturation by allowing the workers to expand too far into available memory. Because the problem there is that if you expand too far, if they use too much memory, you may have the Linux out of memory killer jumping in and killing the workers in a way more bad way. The other going to our next top priority effort is the optimizing the workers that consume a lot of memory and can cause out of memory kills. There is a theme here. So this is a work we have done for a few milestones in the past. We have figured out that there are workers that use too much memory. We have, so for example, some of those may use more than a gigabyte of memory or even go up to 6 gigabytes of memory. This is both inefficient and also resulted in those workers being killed and have to be retried. I'm talking about more than 1,000 out of memory kills per day observed on our background queues. So before we continue, and we have optimized a few workers already, we have decided to first improve monitoring and metrics of workers. Because so that if we have a better understanding of those metrics, we'll be able to figure out which workers have issues. Because at the moment, we are a little bit blind because we don't have all the metrics that we need, as well as there is the problem where when the Linux out of memory killer jumps in and kills a process, this can happen very fast, and the process, the worker may not even have the time to log in, to add the log that I'm being killed because I use too much memory. Or there are other issues, like for example, in the node where you have multiple threads, multiple workers running, one worker consumes too much memory, and then the whole server, the whole node is killed, and you see 6 workers killed, and you are not sure which one was the one that was causing the problem. That can be, we can dive into that, but causes a lot of noise for us. So the idea here is, can we use different and other ways to monitor those problems? One idea is to use the sidekick memory killer. This is similar to the Puma memory killer, which runs, it does not run on a lot of types of nodes in GitLab.com. It runs on only a few workers, types of workers. And the idea here is to enable it everywhere and use it instead of allowing it to kill the processes, to use it as an early warning and log that there is a problem before the Linux out of memory killer gets in and kills the process, so that we have more details, more data. There are 2 things here. The first one is that we have the idea of using this new memory watchdog and making it generic enough so that we can use it both on Puma and sidekick workers. So maybe we don't need to use the sidekick memory killer on that front. So we will first work on this. But the second thing that we want to also do before moving forward is to identify why we also see the sidekick memory killer not being triggered before pods are killed by the Linux memory killer. So we want to identify that and understand what happens with our memory allocation and other triggers that can cause pods to be killed. The second way of addressing this is to use the GitLab Sidekick reliable fetcher. This is an add-on on Sidekick that allows us to track the interrupted count, to track how many times workers have been interrupted. Like, for example, when the Linux out-of-memory killer gets in, interrupts the process and kills the pod. So we will investigate this as well. Finally, our last top priority is creating the custom SLIs for global search. This is to increase the visibility into how our global search works. We're deep into the implementation. We expect to finish that so that will allow, by the end of 15.3, the global search team to have a way better visibility on different types of searches, basic or advanced, and different types of scopes with separate metrics. That's it. Thank you for watching, and talk to you next month.